All right, so think of a propane tank and a propane grill, and the reactants, it's really a chemical reaction that's taking place, right? So the reactants are the propane and the oxygen. So the tank is filled with propane, the oxygen is just from the air, and then the products are carbon dioxide and water. So when you burn the propane, we talked about this yesterday, methane and natural gas burns clean. Because what happens is when you burn the carbon that forms with the oxygen in the chemical reaction by burning, propane or natural gases, and it releases carbon dioxide, which is a gas that doesn't harm us. In fact, we breathe it out. And then it releases the hydrogen, because there's hydrogen in methane and propane too. That forms with oxygen as well, and there's water vapor. So when you burn a clean gas like propane or natural gas, which is mostly methane, and by the way, they're very similar chemically, it burns clean. That's why you don't get a lot of smoke. Now, if you burn wood has extra stuff in it that when you burn it, the ash and the smoke, those are different byproducts. But clean gases, their major products that they release are carbon dioxide and water. However, the description of this reaction is incomplete unless you consider the heat and light that's produced. So when you burn it, there's other stuff that takes place. So what happens to the chemical bonds during the chemical reaction? Well, chemical reactions involve the breaking of chemical bonds in the reactants and the formation of chemical bonds in the products. So remember that this propane is a molecule or compound. We're doing something that breaks those bonds, and then it forms new bonds in a different way. So if you want to look at it, the heat produced by the propane grill is in the form of energy. When you write a chemical equation for the combustion of propane, you can include heat on the right-hand side of the equation. In other words, this is the propane part, this is the oxygen part, and when you burn it, you end up with the carbon dioxide and water, and heat is released. Chemical energy is the energy stored in the chemical bonds of the substance. The propane molecule has 10 single covalent bonds. The chemical energy of the propane molecule is the energy stored in these bonds. Oxygen, carbon dioxide, and water molecules have energy stored in their chemical bonds as well. Energy changes in chemical reactions are determined by the changes that occur in the chemical bonding. In the combustion of propane, the bonds in the propane and oxygen molecules are broken, while the bonds in the chemical dioxide and the water molecules are formed. The breaking of the bonds. In order for combustion of the propane to occur, all the chemical bonds in the reactants, propane and oxygen, must be broken. The formation of the chemical bonds in the products then completes the reaction. Breaking chemical bonds requires energy. A spark provides enough energy to break the bonds of reacting molecules to get the reaction started. So usually when there is a chemical reaction, there's something that you have to do to start it. Sometimes it could just be the room temperature or oxygen. It really depends, but there's something that kind of sparks it. In this particular case, it's literally a spark. Okay. So propane combustion, when you look at this, you have propane, that's this stuff right here, C3H8, 5 molecules of oxygen. Then combustion takes place. You're going to break the bonds of everything. You're going to form carbon dioxide, 3 molecules of carbon dioxide and 4 molecules of water, and heat. Now the bonds, if you look at this, these are the bonds that are broken. These bonds are broken. These bonds are formed. And these bonds are formed. Just a reminder, we covered this before. This is a single bond, right? So there are 8 single bonds between the carbon and the hydrogen. And over here, there are two single bonds between the carbon. Over here, there are 5 double bonds in the oxygen. Okay, we talked about that earlier. Now, what's formed? Well, you have 6 double bonds of carbon with oxygen. And let me break that down for you. This carbon bonds with this, and it bonds with this. Okay. Now, over here, for the hydrogen, you have 8 single bonds with the oxygen and the hydrogen. So the oxygen binds or is bound to one hydrogen and another hydrogen. So that's 2 single bonds. Okay. So forming bonds is another part of the process. So for each molecule of propane burned, 3 molecules of carbon dioxide and 4 molecules of water are formed. And there's literally millions, when you light the gas grill, millions of these molecules instantaneously do this. Okay? So there are 6 carbon-oxygen double bonds and 8 oxygen-hydrogen single bonds that are formed. Now, pay attention to this because this stuff is going to be in the reading guide. The formation of chemical bonds releases energy. So you could release energy by, you got to use the energy to break bonds, but when you form bonds, you release energy. So just think about that too. The heat and light given off result from the formation of new chemical bonds. So it's not the breaking of the bonds that releases the light and heat. It's the formation of the new bonds. So what happens to the energy during the chemical reaction? Well, during the chemical reaction, energy is neither released or absorbed. So it's very similar to a phase change, right? If I heat something up, if I heat up water, the instant it starts to go from liquid to a gas, the temperature doesn't change because that energy is being used to do that transformation. The same thing for a chemical reaction. It's not until the new bonds are formed that the heat and light are released. So combustion is exothermic reaction. So let's review what a chemical reaction is. It says that a chemical reaction that releases energy to its surroundings is called exothermic, right? Thermic meaning heat, exo meaning outside. So you're releasing heat to the outside. In exothermic reactions, the energy released as the products form is greater than the energy required to break the bonds. Now the reason for that is because there is energy stored in the matter. The elements, the atoms, the molecules have energy. They have kinetic energy. There are bonds that contain energy, and you're releasing that energy, but you just have a spark. When you put things back together, you're going to have more energy. Actually, you have to be careful. Energy can't be created or destroyed. But the amount of energy, a spark is all it takes to get the fire going. Okay? Then the heat energy that's released is absorbed by other molecules. It just starts kind of a chain reaction. So combustion is extremely exothermic reaction. 1 mole of propane reacts with 5 moles of oxygen. And it generates 2,220 kilojoules of heat is released. So before we just wrote heat, but if you want, you can actually calculate how much heat is released. Now we're not going to do a whole lot of that in your ICP class, but if you were to take a upper level chemistry class, you would have to calculate that. So what does it mean? Well, in an exothermic reaction, the chemical energy of the reactants is greater than the chemical energy of the products. So what they're saying is if we consider the chemical energy in the reactants themselves, you have far more energy than you do in the products. And this all happens during the reaction process. So you have reactants just sitting here, the spark happens, boom, there's a huge release of energy, and then as the products are formed, the energy goes down. And that energy is used to form the products, but it is also released in the form of heat and light. Mostly heat for exothermic. So this energy, this gap right here, is from the energy being released by the reaction. So when I have propane gas and oxygen sitting still, boom, spark, boom, chemical reaction takes place. A ton of energy is released when the products are formed. In a chemical reaction, the chemical energy reaches a peak before the reactants change into products. A bunch of bonds are being broken. Okay? This peak represents the amount of energy required to break the chemical bonds of the reactants. Particles must collide with enough energy to break the bonds, or the reaction will not occur. So basically what happens is that spark is enough energy to set one molecule on fire. When those molecules are released, they can bump into other molecules, releasing other bonds, and then it starts a chain reaction. Endothermic is the opposite. That's where you absorb energy. So a chemical reaction that absorbs energy from its surroundings is called endothermic. An endothermic reaction, more energy is required to break the bonds and the reactants than released by the formation of the products. So in an endothermic, you have reactants here. They have to absorb energy from their surroundings. That energy goes into breaking bonds, and then it peaks right here, and then there is a little bit of a release when the products are formed, but it's a little bit backwards. The energy is absorbed by the reaction. So at about 450 degrees Celsius, mercury oxide decomposes into oxygen gas and liquid mercury. So here you have a compound that if you heat it up, it will literally break down. So the orange-red powder in the bottom of the test tube is mercury oxide. When the powder decomposes, oxygen escapes from the test tube, mercury collects in droplets on the side of the tube. So here we have the mercury oxide. You heat it up. Once it reaches 450 degrees Celsius, mercury liquid is right here. Okay, the oxygen is released through the tube. It just kind of floats up. Okay. Now, in an exothermic reaction, the chemical energy of the reactants is converted into heat plus the chemical energy of the products. In an endothermic reaction, the heat plus the chemical energy of the reactants is converted into chemical energy of the products. In both cases, the total energy before and after the reaction is the same. This principle is known as the law of conservation of energy. In middle school and in elementary school, we always tell you energy cannot be created nor destroyed. Whatever is will always be. It just gets transferred. During a chemical reaction, an input of energy is always required to A, break chemical bonds in a molecule, build chemical bonds as a molecule forms, separate products from the reactants, or D, change reactants to a liquid phase so they can react. What do you guys think it is? It's A. Break chemical bonds into a molecule. In an exothermic reaction, the total chemical energy of the products added to the energy released by the reaction is A, less than the energy of the reactants, equal to the chemical energy of the reactants, greater than the chemical energy of the reactants, or not related to the chemical energy of the reactants. What do you guys think that one was? It's B, equal to the chemical energy of the reactants. Combustion is always an exothermic reaction. True or false? True. Whenever you burn something and it unites with oxygen, heat and energy is released. That's it. That's all I got for you guys today. So your assignment is